Okay, thank you so much for your nice presentation. My name is Stefano Rinaldi. I'm electronic engineering from the Department of Information Engineering. I'm an electronic engineering, so during this presentation I give you probably a particular point of view. But I work very close with civil engineering of my university for the automation of a construction site. So today I'm here to present you a communication technologies, in particular LoRaWAN, that can be used for an extensive application of Internet of Things paradigm to construction site. First of all, let's start from the advantages of the use of Internet of Things paradigm inside the construction site. Part of these advantages are very well known, of course. For example, using an extensive usage of communication technologies inside the construction site, we can optimize the construction phase, optimize the supply chain, and overall we can improve the construction site security and the safety of the worker inside of the construction site. All these benefits coming from an extensive availability of data directly from the construction site. So the first step in order to get data from the construction site is the digitalization of the construction site. We can digitalize the construction site through the installation of sensor, physical or virtual, inside the construction site, or collecting the information from the automation system available inside the construction site. All this data generated from devices installed in the construction site should be transmitted using a communication network and finally collected in a remote cloud server for data storage and cloud computing. But let's enter more in detail in this in the digitalization of the construction site. The first step in the digitalization of the construction site is represented by the so-called cyber-physical system. What is a cyber-physical system? A cyber-physical system is just a set of mechanical, electrical, and electronic components that allow the interaction between the physical and the cyber world, as clearly shown by the name. Basically, a cyber-physical system is a microprocessor with sensor or actuator used for the data collection directly for the physical object. The second step is the Internet of Things. Internet of Things is related to how the data of an object is modeled and is exchanged between different users of the data. The target of an Internet of Things is to allow the access to a user, human or another machine, to the data of a physical entity. A physical entity represents the object the user wanted to have access. But what practically we need to realize an IoT system? Basically, we need to integrate it inside in each object the functionalities you show here in the slide. In particular, we need to include inside in an object technology in order to be able an auto-identification of the object, technology for sensing and communicate, technology for manage of the data, and technologies used for the data exchange, the language in particular. But now focus on a more on an example of what I'm discussing here. An example of a cyber-physical system is, for example, a machinery, a set of hardware, electronics, mechanical components, which is used for the interaction with the real world. the data model of such a cyber-physical system are the part of the so-called virtual model, the digital twin of the real system, of a physical system. Basically, a digital twin are all the information that can describe the complete functionalities of a cyber-physical system. And the second part of the IoT paradigm is how this digital twin can interact and exchange information with other components inside the construction site. And all this information are related to the digital twin can exchange data using specific protocols and using proper communication technologies. And in particular, the transmission technologies used for exchange of this data inside the construction site is the target of my research today. Regarding the first part of a communication target, nowadays there are several communication protocols that can be used to exchange data between the different objects inside the construction site. Some of them, like the very well-known web service RESTful, basically use the traditional HTTP protocols for the data exchange between the object. Basically, we use the same protocols used for the data exchange inside on the internet, the traditional internet, for the data exchange between different objects. Another protocols very used, very common inside in Internet of Things paradigms is called MQTT. Basically, it is an improved communication protocols optimized for the communication of objects with very low power and low communication resources, like generally IoT devices are. The problem is that all these communication protocols I showed you in the previous slides basically are based on traditional TCP/IP stack, the normal internet communication system. The problem is how to transfer this communication, to map this communication protocol on different communication technologies inside the construction site. That's the real problem, because inside the construction site we have different objects that need to communicate. We have communication between objects inside the construction site, like, for example, machineries, workers, and objects inside the construction site, and the rest of the supervision system of the construction site. In particular, we focus on the communication technologies connecting field-level devices with the supervision system. Because we not during this presentation don't focus on the communication between objects inside the construction site. An example of this communication between the so-called machine-to-machine communication is, for example, the communication technologies we can use for the design of a proximity warning system inside in a construction site. The problem of this kind of communication is that generally very specific, depend by the specific applications. While for the communication in the IoT paradigm, we need communication technologies able to connect as more as possible devices inside the construction site, with the support of, and generally, we need a wireless communication system. In the family of the communication system, there are several communication technologies, and one of the most interesting from the point of view of construction site are the so-called low-power wide area network. This kind of technology is optimized for the transmission of data over a long range using very low power device at a very low cost. For example, the cost of a full LoRaWAN network is on the order of hundreds of euros. If compared to the 1,000 euros of a 5G network, the cost is very limited. LoRaWAN, as you can see, is optimized for the communication of very low power devices, and the target of this kind of solution is to allow to very low power and simple nodes an access to Ethernet. The problem of this kind of network is generally the LPWAN network are not optimized for huge data rate transmission and are optimized for sporadic transmission of data. The benefits is that generally this solution transmit the data in unlicensed band. So basically, we don't need to pay for a SIM card to an operator in order to transmit in this band. The architecture of a LoRaWAN network, one of the most used LPWAN solution, is similar to the architecture of a traditional 5G network, but the cost in this case are very limited. As mentioned in the previous slide, the LoRaWAN network are not optimized for the transmission of a huge amount of data. And so one of the parameters we evaluate in an experimental setup is the total time the information required from the end node to be received by the cloud system, one of the important parameters from the point of view of the user of this data. And we design, using our components, an experimental setup to characterize this delay, and we obtain, as you can see here from this table, as the average end-to-end delay is on the order generally of 500 milliseconds. Is the time the information required for coming from the fields to reach the cloud system. And for large set of applications, this communication delay is more than enough. So, just concluding, which are the application, the killer application of these technologies in the construction site. All the application that does not require a huge amount of data to be exchanged. For example, environmental monitoring or monitoring of some of the parameters of a construction site. All the application where, for example, we don't have 5G coverage. All the application where the sensors are distributed over a large area. Of course, we have some limits of this. Some of the limits of these technologies are that we cannot use these technologies in order for control loop inside in the construction site. So, in conclusions, the Internet of Things technologies are changing several industries, including the construction site. And one of the main obstacles of a large usage of Internet of Things part inside the construction site is limited availability generally of a communication infrastructure inside the construction site. So the usage of these kind of technologies, the LoRaWAN, is a promising technologies to provide a connection to devices installed in construction site. Thank you for your attention.